Hello, welcome to the course Fundamentals of Physics 1, and in this video I am going to talk about measurement, theory of errors and scalar vector. Measurement is really important and it plays an important role in our daily life. Measurement is the action of measuring something. We can measure the size, length, amount of something, etc. And it is the basis of all scientific studies and experimentation. So, measurement is the act of determining a target size, length, weight, capacity or other aspect. And it shows the measured result using values and symbols. Measurement refers to the quantification of results obtained by using measurement tools. These are some devices used for measurement. This is common balance, spring balance. Both are used for measuring the mass. This is the clock, which is used for measuring the time. This is the ruler, which is used for measuring the length. Okay, then what is measurement? Measurement, it's the comparison of any physical quantity with its standard unit is called measurement. So physical quantity is the property of an object that can be quantified. There are two types of physical quantity, fundamental quantity and derived quantity. Fundamental quantity is also called as base quantity. It is the quantity which cannot be expressed in terms of any other physical quantity. There are 7 fundamental quantities: length, mass, time, electric current, temperature, amount of substance and luminous intensity. These are the fundamental quantities. And derived quantities, it is a quantity that can be expressed in terms of fundamental quantities. For example, area, volume, velocity, acceleration, force, energy, density. These are all derived quantity. Area means is length into breadth. Length is the fundamental quantity and breadth, that is also the length, right? It is the fundamental quantity. It derived from the fundamental quantity. See, the velocity, it is displacement divided by time. Displacement is the fundamental quantity and time is the another fundamental quantity. So it derived from the fundamental quantity. So it is called derived quantity. Right. Then unit. Unit is used in physics, refers to the standard measure of an quantity. Right. It is an arbitrary chosen standard of measurement of an quantity which is accepted internationally is called unit of the quantity. There are two types of unit, fundamental or base unit and second one is derived unit. Fundamental unit, it is used for measuring the fundamental quantities, that is measuring the length, mass, time, electric current, temperature, amount of substance and luminous intensity. These units, the fundamental units, are used for measuring these 7 fundamental quantities. That is, the unit of length is meter, the unit of mass is kilogram, the unit of time is second, electric current ampere, temperature is Kelvin, and the unit of amount of substance is mole, and the unit of luminous intensity is candela. This is the fundamental unit. And derived unit, that is this derived unit used for measuring the derived quantities, that is the unit to measure these derived quantities, that is the area. Area is length into breadth. The unit of length is meter and the unit of breadth is also meter. So the unit of area is meter square. This meter square, it is a derived unit. And the unit of velocity, that is displacement divided by time. The unit of displacement means that is distance, that is also a length, right? So the unit of the displacement is meter and the unit of time is second. So the unit of velocity is meter per second. That is derived unit. Okay. Then the common systems of unit. There are three common systems, that is FPS system, CGS system, MKS system. FPS, that is foot, pound and second, right, which is used for measuring the length, mass and time. F foot, that is for measuring the length. P pound, that is used for measuring the mass. And S second, that is used for measuring the time. Then second one, CGS, that is centimeter, gram, second. So which is used for measuring length, mass and time. And MKS, that is meter, kilogram, second, which is used for measuring length, mass and time. Okay. Then SI unit system. The system of units used by scientists and engineers around the world is commonly called metric system. Since 1960, it has been known officially as International System, that is SI unit system. Okay, then next, measurement of basic quantities. Length, mass, time, these are the basic quantities. How to measure these basic quantities? First, measurement of small distance, that is the distance ranging from 10 to the power minus 5 meter to 10 to the power 2 meter can be measured by direct method. We used some devices to measure this small distance, that is meter scale, vernier caliper, screw gauge. These are the devices used for measuring the small distance. Meter scale. This meter scale is used to measure the distance range from 10 to the power minus 3 meter to 1 meter. And vernier caliper, which is used to measure the distance up to 10 to the power minus 4 meter. And screw gauge is also called as micrometer, which is also used to measure the distance up to 10 to the power minus 5 meter. These are the devices used for measuring the small distance. First one is ruler. Second one is vernier caliper. Ruler is used to measure the length. Length means it's distance between any 2 points, right? This ruler is used to measure the distance. And vernier caliper, it is used to measure the linear distance, that is the diameter of the ball, inner diameter or outer diameter of the diameter of the scale, ruler, etc. And screw gauge, which is used to measure the linear distance, that is the small distance, thickness of the wire, etc. Right. And next, devices for measuring length. These are the ancient instruments, that is footstep, a rope, handspan, arm length. These are the ancient instruments. These are the modern instruments, that is ruler, measuring tape, screw gauge, vernier caliper. Right. Then measurement of large distance. Okay, there are three methods to determine the very large distance. They are triangulation method, parallax method and radar method. So measurement of large distance, that is for measuring the large distance such as height of the tree, distance of moon or other planet from the earth, we can use some special method. First one is triangulation method. This method is used to measure the height of an accessible object. For example, we can measure the height of the tree or tower. See this diagram. AB is the height of the tree and C is the point of observation at the distance X from B. So place the range finder at C and measure the angle of elevation. So from the right angle triangle ABC, we know that tan theta is equal to opposite side divided by adjacent side. In this triangle, the opposite side is AB. So AB divided by adjacent side is CB. So AB divided by CB. So AB is equal to H and CB is equal to X. So tan theta is equal to H divided by X. From this we can find H, height of the tree, that is H is equal to X tan theta. So knowing the distance X, we can determine the height of the tree. This is the first method to find the height of the tree or to find the height of an accessible object. Then second one is parallax method. This method is used to measure very large distance such as distance of the planet or stars from the earth. So let's see how to determine the distance of moon from the earth. In this diagram, M is the moon, C is the center of the earth, A, B is two opposite places of the on the surface of the earth, and this AB is the diameter of the earth, and this angle theta 1 and theta 2, two parallaxes from A and B of the moon M with respect to some distance. This theta 1 and theta 2 can be determined with the help of an astronomical telescope. So the total parallax of moon is theta 1 divided plus theta 2, that is equal to theta. Theta is equal to theta 1 plus theta 2. So from the triangle AMB, theta is equal to AB divided by AM. Here AM is approximately equal to MC. So theta is equal to AB divided by MC. From this we can find MC. MC is equal to AB divided by theta. So knowing the value of AB and theta, we can find the distance. So AB, that is the diameter of the earth. We know that the radius of the earth is 6.4 into 10 to the power 6 meter. From this we can find the diameter, that is 2 into radius, that is diameter. So knowing the value of AB and theta, we can find the distance, right? Then third method, that is a radar method. Radar stands for radio detection and ranging. This method is used to measure the distance of nearby planets such as Mars. Okay, in this method, radio waves are sent from the transmitter. After reflection of the signal from the planet, it is detected by the receiver. So, by measuring the time interval between the radio waves are sent and received, the distance of the planet can be determined. Okay, we know that speed is equal to distance divided by time, right? So, here the speed is distance traveled divided by time taken. That is, it is from this distance is equal to speed into time. So distance d is equal to v into t divided by 2. Here v is speed of the radio wave and t is the time taken and d is the distance traveled. Okay, as time taken is for the distance covered during the forward and backward path of the radio waves, so it is divided by 2. It is also used to determine the height at which an aeroplane flies from the ground. Then next one is next physical quantity, that is mass, measurement of mass. Mass is the property of matter, right? And the quantity of matter contained in the body, that is mass. The SI unit of mass is kilogram, and some of the weighing balances used are common balance, spring balance, electronic balance, etc. Okay. And for measuring large masses like planets, stars, we can use gravitational method, and for measuring the small masses of atomic particles, we use mass spectrograph. These are the some devices for measuring the mass. Okay, next one is measurement of time interval. That is, time is another physical quantity. Okay, to measure the time we use clock, right? Clock is used to measure the time interval. So some of the clock developed later are electronic oscillator, electric oscillator, solar clock, quartz crystal clock, atomic clock, etc. These are the some devices used for measuring the time. Okay. Next one is scalar and vector. Okay. Scalar. Scalar is the property which can be described only by magnitude. It can be described only by magnitude, and vector is a quantity which is described by both magnitude and direction. So the example of scalar is distance, mass, temperature. These are the scalar, and the example for vector is force, velocity, displacement. This force which has both magnitude and direction. Velocity have both magnitude and direction, right? So these are the vectors. Then magnitude of vector. This magnitude, it is also called as norm of the vector, or the length of the vector. The length of the vector is the magnitude of the vector, and it is always positive quantity. It is denoted by modulus A vector, right? There are different types of vector: equal vector, collinear vector, unit vector, orthogonal vector, right? First one is equal vector. If two vectors have equal magnitude and same direction, it is called as equal vector. In this figure, A and B are the two vectors. Both are same direction and the magnitude also same. For example, if A is 5 unit, B is also 5 unit. 5 is the magnitude, right? That is the length of the vector. If both magnitude and directions are same, this vector is called as equal vector. Next one is collinear vector. It acts along the same line. The angle between them is 0 degree or 180 degree. This collinear vector is classified into two types: parallel vector and anti-parallel vector. Parallel vector means if two vectors act in same direction along the same line or parallel, it is called as parallel vector. In this diagram, two vectors A and B both are in same direction, but the magnitude is different. That is parallel vector. And anti-parallel vector, that is if two vectors act in opposite direction along the same line or parallel line, it is called as anti-parallel vector. Here in this diagram, A and B, two vectors, both are in opposite direction, and or the angle between these two vector is 180 degree, right? Next one is unit vector. Unit vector, that is a vector divided by its magnitude, is called unit vector, right? This is called as A cap. A cap is equal to A vector divided by A. That from this, A vector is equal to A cap, right? Next one is orthogonal vector. Two vectors which are perpendicular to each other is called orthogonal vector. Here I, J and K are the three unit vector along with positive x-axis, positive y-axis and positive z-axis. These three vectors are perpendicular to each other and the angle between them is 90 degree. So it is called orthogonal vector. Right. Next, addition of vector. How to add two vector? Okay, vector cannot be added by ordinary algebra method. It can be added geometrically using certain rules called vector algebra. Okay, to find the sum of two vector which are inclined to each other, we use two methods. First one is triangular law of addition method and second one is parallelogram law of vector. Okay. First one is triangulation law of addition method. Here, this is A vector, this is B vector. A and B are the two vectors. The arrow side of this vector is the head and the opposite side is the tail of the vector. Okay. To find the sum of two vector, we apply triangulation method. So to add the two vectors, the head of the first vector is connected to the tail of the second vector. This is the head of the first vector. This is the tail of the second vector, which is connected, and we will get the resultant vector R is equal to A vector plus B vector. So these A and B are the two adjacent sides of the triangle. So in this diagram, OQ, that is resultant vector R vector, which is equal to OP, that is A vector plus PQ, that is B vector. And how to find the magnitude of the resultant vector? So this is A vector in this diagram. This is A vector, this is B vector, this is the resultant vector. Here, extend the side of OA to ON, we get the right angle triangle ABN. So consider this triangle ABN, right? In this triangle, this is theta, the angle, this angle is theta, and take this triangle BAN. We know that cos theta is equal to adjacent side divided by hypotenuse. So in this triangle, opposite side, that is AN, divided by hypotenuse is AB. So cos theta is equal to AN divided by AB. The value of AB is B, right? Which is equal, from this we can find AN. The value of this AN is B cos theta. And take the same triangle to find sin theta. Sin theta is equal to opposite side divided by hypotenuse. So here the opposite side is BN divided by hypotenuse. The value of hypotenuse is B. So BN divided by B. From this, BN is equal to B sin theta. Now we know this value BN, that is B sin theta. Now we take this triangle BON. This angle is alpha. Take this triangle BON. According to Pythagoras theorem, OB square is equal to ON square plus BN square. So here ON is equal to OA plus AN. Substitute this value. OB is equal to R. So OB square is equal to R square. This is equal to OA, that is A, plus AN, that is B cos theta, the whole square, plus BN, that is B sin theta, the whole square. So R square is equal to, expand this A plus B cos theta the whole square, that is A square plus B square cos square theta plus 2AB cos theta, that is A plus B the whole square is equal to A square plus B square plus 2AB. So expand this, and B sin theta the whole square, we can write this as B square sin square theta. Okay, here B square cos square theta, here B square sin square theta, B square common, so you take this outside. a square plus b square cos square theta plus sin square theta plus 2ab cos theta. Okay, we know that cos square theta plus sin square theta is 1. So r square is equal to a square plus b square plus 2ab cos theta. From this we can find r. Magnitude r is equal to square root of a square plus b square plus 2ab cos theta. Right? Next, find the direction of the resultant vector. Here you take this triangle BON. In this triangle you take the tan theta. Tan theta is opposite side divided by adjacent side, right? Here opposite side is BN. BN divided by ON. BN divided by ON. ON we can write this as OA plus AN. So substitute this value, you will get tan alpha, that is B sin theta divided by A plus B cos theta. From this we can find alpha, that is tan inverse B sin theta divided by A plus B cos theta. Right? This is the direction of the resultant vector. Okay. Next one is subtraction of vectors. Okay. Vectors cannot be subtracted by ordinary method. It can be done either geometrically or analytically. Here we use parallelogram law of subtraction the vector from other. Okay, here A and B are the two vectors inclined each other at the angle theta. This is A vector, this is B vector. So this is the positive side of B, positive side. So you extend in opposite side, you will get negative B, right? Minus B. Oh, so you extend this line, you will get the parallelogram. And this angle is theta. So the total angle is 180 degree. So this angle is 180 degree minus theta, right? So here this side is theta, this side is this angle is 180 minus theta. Okay, here we use the same formula that we found in the vector addition, that is r is equal to square root of a square plus b square plus 2ab cos theta. Here we use the same formula. Instead of this cos theta, here we use cos 180 minus theta, right? Cos 180 minus theta. So the modulus a minus b is equal to a square root of a square plus b square plus 2ab cos 180 minus theta. We know that cos 180 degree minus theta is minus cos theta. So you substitute this here, you will get square root of a square plus b square minus 2ab cos theta. And to find the direction, we use the same equation. Tan alpha is equal to b sin, instead of theta we use 180 degree minus theta divided by a plus b cos 180 degree minus theta, and sin 180 degree minus theta is equal to sin theta. You substitute this, you will get tan alpha, that is b sin theta divided by a minus b cos theta, right? Okay, next one is scalar and vector product. Okay, first scalar product. Scalar product is also called as dot product. Scalar product of two vectors is defined as the product of the magnitude of both vectors and the cosine angle between them. So A vector dot B vector is equal to AB cos theta. Here A is the magnitude of A vector, B is the magnitude of B vector, and cos theta. So it is the product of the magnitude of both vectors and the cosine angle between them. That is scalar product. And vector product, it is also called as cross product. So we use this symbol, cross product. This is the product of the magnitude of the vector and the sine angle between them. So the vector product is defined as the product of the magnitude of the two vector and sine angle between them. Next one is, this is a comparison table between dot product and cross product. First one is general definition, that is what is dot product and what is cross product. Second one is mathematical relation, that is a dot b is equal to ab cos theta, here a cross b is equal to ab sin theta. Then a resultant, that is the dot product is the scalar quantity and the cross product is the vector quantity. Then orthogonality of vector, that is the dot product is 0 when the vectors are orthogonal, and for cross product it is maximum when the vector is orthogonal. And commutative, that is the dot product of two vectors follows the commutative law, that is a dot b is equal to, we can write b dot a, but in cross product it is not commutative, so a cross b is not equal to b cross a, right? These are the vectors. Then theory of errors. First, what is error? Error means the result obtained from any measurement will contain some